approximately. At 10 o'clock.
Okay, madam.
Так, something I have explained it before we started record. I hope, I hope it will work well. Previous record, once again, do not remember whether I already downloaded to chat or not. Later
No.
will check and remind me. Not yet. Very well. I will find it in my mail, this link, and will download it to YouTube, to chat, and so on. We once already did this. We're talking about Sylvan frame. Sylvan frame. Wait a second. First, we have drawn in the view of. It's not even breakdown view, no, something like that. In the view of kit of parts, the only parts which are absent here are stiffeners. Stiffeners we haven't drawn. We meant that they exist here in assembly, but we have not drawn it in this kit in order not to litter, let's say, the picture even more. We meant them as green parts in this three-dimensional sketch, but have not drawn it here. So it consists of three webs, left and right practically identical, symmetrical, like mirrored. It consists of rims which touching the skin, these orange parts, rims. And also they have caps, what we're calling caps. It's extruded profile which cut and bend to proper shape, and also rims, outer caps and inner caps. They they broken onto three portions: top one, center one, left and right. And of course, where they have this breakage, the places of splitting of as webs, as rims and caps, supposed to be some joining additional doubling parts which join elements and increase this place in terms of their strengths. So we have joining pads. I hope you see between, oh, sorry, I made wrong. I meant to do it like this. Now, joining pads on the left, on the right. And we have joining profiles, little parts, also extruded little parts. In order to catch your attention, what it looks like, here is those parts. They are shown how it's joined. When we draw this kit of parts and start thinking about how to assemble it, first thing that we understand, we need to select some methods of assembling. How we're going to locate parts, how we're going to find their position with respect to each other. Right now, we'll not remind what we have decided in general. In the more general, webs located by CFH, you see this, forgive me, ugly sketch. In the big picture, it's visible locator of CFH, and light green color, it's locator of contour frame. And all other parts, practically all another parts, they are located by assembly holes. Maybe besides of little profiles and pads, they don't need actually even assembly holes for their locating. Under this picture, you see a couple of variants of locating chart in cross section. And what is the difference in this locating chart? To remind you, it comes about which part is located first. In case web is located first, science looks like this. In case rim is located first, science looks a little bit different. In general, everything is similar, but science might be a little bit different. Now, let's see what we have decided. What is first? Rim is first. Very well. So first we locate rim, and simultaneously with this we also, let's say, have imagined the scheme of jig. First we locate rims, these orange parts, to the light green locator, which is continued as horseshoe. It looks like horseshoe. It's maybe in such position, it may be in upside down position during assembly. It doesn't matter. You just need to decide what is convenient for your employee to work, and what uh, take you less auxiliary means in order to provide their work, let's say, how to place it. horizontally, vertically in which position. No, let it be right now, it's like this. And once again, rim located to locator of contour, web located onto locators of CFH. They are symbolically represented on the left. Now, let's come back to this place. What we have decided that we are locating rims next webs. To the webs and rims we are locating caps. Why it's important to have cap or to have web between rim and caps? I hope you do remember, because web is really inside, no, between some elements. Next, we are adding these pads and next stiffeners. To be frank, practically all these stiffeners might be even sub-assembled with the web. Instead of what we have shown right now, it might be also something like, it's to the question of diagrams of assembling, sequential or non-sequential. So look, what we did here. We have web, no, this web, and we have, let me do a drawing, not like this. Oh, I thought to move it down. By the word, it's one of my singer right now has appeared in the screen for some seconds. She's in France now. She was forced to leave Kharkov previous summer, and she now is in France. Look, for instance, we might do so-called sub-assemblies. Let's replace this one temporarily. Let's imagine that our webs is preliminary, already like mounted a little bit, joined with stiffeners. And it means that you have here additional elements. No idea how to call them. No, let it be assembled web. Assembled top web. It means that it's already assembled with stiffeners. Next. Not much good. Assembled side web. And in this diagram, it will be also shown how they are. Sorry. Something like this. Да? So we have line of parts, we have sub-assemblies here, да? As you might see. Practically, it changed nothing in this meaning, in meaning of coordination, completely nothing. But what is the difference between this diagram and diagrams that we might see here? No? The difference in the time of, in the time of using the jig. When you have preliminary assembled webs with stiffeners, you don't need to use jig all the period until you locating the stiffeners. Actually, all the stiffeners located by assembly holes to the webs, yes? And you don't need to use jigs for period of locating of stiffeners. You don't need to make riveting joint there in case you rivet immediately in a jig. And it means that shorter using of jig will be provided in this case. But in this particular case, there is no another difference with first and second diagram. Which is better, once again, which girl is better out of three girls, which one is better? No one is better. It depends on your need. The same is here. Is it better that you use jig shorter period? Depends
But
on.
without experience, how can a student say, like, I feel
So one,
both are
we're
same?
talking about students, we're talking about real life. Real life, in real life, you have program of manufacturing. And
Okay.
in real life, according to this program of manufacturing, you are estimating how long you, look, first, for instance, do you imagine, in during 1 year, we have 52 weeks. We will use very simple values in order you might understand clearly. For instance, you need to produce 104 airplanes per year. How airplanes per year you need, how airplanes per week you need to produce?
Yeah, two per week.
Two airplanes per week. How such frames per week you need to produce? No, one plane, one frame, yes?
Yeah, for example, if one plane is one frame, we need to
No,
make two
in two
frames per
particular
week.
case. Yeah, you need to produce two jigs during the week, yes? Now, what is the working time of the week? If we're talking about one shift work, 1 hour, one shift, 8 hours, five working
40
days,
hours per week.
30 hours. Yes, exactly. Do imagine that you need to produce 20 frames during 40 hours in a jig. If your jig, you have one jig now, let's imagine we have one jig. It's able to work not even 40 hours, no, theoretically at least. Jig working a little bit less because you need some time for it work with, let's say, coefficient. No? Coefficient approximately 0.9. It means that 10% of jig life we are spending for its inspection, repairing, and so on. Let it be even jig also working 40 hours per week. No? Let it be. And do imagine that your frames, one frame to assemble, you have 15 hours. You need to produce two frames, one frame you're assembling 15 hours. Two frames are 30 hours. Yes?
Yes, madam.
Look, jig is able to work 40 hours and you need to use it 30 hours. It's enough for you, one jig. Should I write it in front of you with values?
Don't write it. Please don't
No.
write.
Yeah, no. Say me, is it enough one jig if you have 30 hours to work and jig is able to work 10 hours more? Enough one jig
Yes,
to have?
enough.
Enough. But do imagine that you need to produce 20, you need to produce again two frames, but when you calculate time, for instance, for this bottom diagram, it's a period, what for this diagram that is at the bottom, it's a period that it's enough 15 hours, да? When you calculate time of technological process, which reflected at the top diagram, it's a period that you have 21 hours to assemble the frame.
Yeah,
Understand?
so, yeah, I
And
understand.
in order to meet demands of your program, you need jig to work 42 hours per week. But jig is able to work only for 40 hours per week. And plus actually time for inspection and so on. Now, what are possible decisions? Either you need to use another jig, but in this case, it's a period that one jig is working 40 hours and another, no, theoretically at least, If you have two jigs, it's 80 hours, you need 42 hours, 38 hours, two jigs are empty. Oh, like simultaneously, that would together.
I
You
get it. And
have money for a couple of jigs, but they are empty. Or you have this slight changing, let it be, in technological process, which resulted that you are it resulted in your ability to no, stick out, let it be, да, in the this bottleneck, I mean time, да? No, I hope you understood. Or if you see that, for instance, you have to produce 5 frames per week, not let it be, да, 26, 260 airplanes per year. No, it's some fantastic values, not even Boeing produce something like this. But you see that you have, for instance, 5 frames, да, and anyway, you are forced them to use, I don't know, 3 jigs. You are forced to use these 3 jigs anyway. Uh,
understood.
Understood? In real life, there are some different factors which are taken into consideration. For you, for student, just a game, do forgive me. It's about nothing. Yeah? Yeah. Let's close this bottom one in order. That one is just more simple for us to draw. So that is why we leave it. And now what we are going to do, look, also, I hope you do remember that once we spent even 2 classes to talk about jigs and jigs coordination, and it's appears that even when we have two, no, we have identical jigs actually, yeah? It's appears that we have two variants of coordination here, what diagram of coordination may be different depending on which technique you're going to use. Technique with special carriers of sizes, by coping of sizes of jig, and in this case you have no you're not interested in position of mounting holes. You have it, but you are not trying to measure their position at all. Wherever they are just holes for joining with frame, no, with skeleton of jig. And if you using so-called instrumental means for mounting the jig elements together, for assembling the jig elements together into the whole structure, by instrumental measuring means, it's a period that you must measure this mounting hole position both in skeleton of jig and in locators, wherever they are existing locators, because you're relying upon the mounting holes grid, let it be, of sizes, no? Because it clearly looks like grid in spatial jig. You rely upon the coordinates like to new coordinate system of your jig. And in this case, you included inter chains of coordination and so on. They exist in both of cases, but in one case it's important, in another case it's not important, their position. Now let's come back here. Now we're going to talk about very complex things. Not really very complex, but students don't like them. And do forgive me, maybe I have not enough place here to show something. So time to time I'll be interrupt this diagram to show something else. And what I propose to start with, not even with the rim, but with the simplest part. What is the simplest part here? Simplest part here is,
Web.
да, exactly. Wait a second, let's open your group separately. I have prepared those pictures once, dropping it to your chat, litter in your chat. Да, them. And in some seconds it starts working properly. I know. But by now, of course, it's кошмар. No, until we are waiting, let's imagine what we're working with now, what we're dealing with. Say me, please, web made of metal sheet, extruded profile, or it's forged part?
Sheet metal.
Sheet metal. And how we're going to work with this sheet metal? What is a typical technological process? I already sent you sometimes
Assembly
video.
hole method.
Forgot about assembly holes. How we're going to work with it during manufacturing the part? How we're going to produce the web?
Cutting.
Cutting. No, if we have, for instance, I will try to use this now. Or at last, it's that one. And exactly at the necessary place. Look, no, that one. Look, in order to produce web of such a rib, or web of frame, or whatsoever. No, in the one case, it has no flanges at the sides, but it has flange around of holes. Some of webs, they have flange around of these big holes for enlightening the structure, yeah? For reducing the weight. And in order to produce those parts, how we are working usually. First, we have, they are called workpieces. Now, these workpieces are cut from the whole sheet to the shape which practically repeat the ready part with additional allowances, additional material for flanges in case you have flanges, and those holes which are holes for reducing the weight. They, of course, now they are cut preliminary, but they are much less in diameter than necessary. Next, after the flanging, they would be much greater, those holes. And preliminary, you might do also assembly holes, for instance. Here, it certainly comes about couples of assembly holes, as we might see in such a photo. What? Oh, sorry. What is next? What is
Those
the next?
assembly holes are for rivet, right, ma'am?
Next, they would be used for riveting. Yes, they might be used for riveting. But as you might see, what do I see in this photo? Those holes being made by not by drilling. What in this particular parts seems like holes made not by drilling, not by milling. They've been done by punching. That is why here it's deformation around the holes. You might see. Yes. And
Yes, ma'am.
more probably the edges of those holes, they are not correspond, they do not correspond to demands of riveted holes, of holes for riveting. So it means that no, in real life, normally in real life, in your two-ish technological process in which our works and our laboratory work, we say that assembly holes are ready holes for riveting. In real, it's not like this. In real, first we assemble onto these holes, locate onto these holes. Next, we do another holes, clean holes for riveting. Next, we insert additional clamps, additional pins into new appeared holes, in couple of new appeared holes. We remove clamps from the holes that we call assembly holes. We change diameters and quality of edges of those holes, and then they are already quite the same as all another holes for riveting. Or they might be, they are not compulsory holes for riveting. For instance, designer permit you to have extra holes here immediately in structure. No, like CFH, they are normally permitted by designer. Да? Those holes that we might see in a rib, these extra holes, they are not necessary. At design point of view, in design point of view, they are completely extra holes. They are not necessary. I mean, these little ones, да? Not visible like this. No, those holes, you see. Quite clear that designer permitted this. Without permission of designer, we don't do such things. Uh, might happen also in this case. Да что ж такого? Wrong place have chosen. That designer permit you to have perforation in those places, but really you are not going to use them next for riveting. No, don't ask me how. It's maybe, for instance, not riveting even. It may be spot welding in this place, or it may be some adhesive joint, or whatsoever. We don't see it. We do not know what is next in this particular case. Um, this space of variance, variety of variance, so on, it's something dreadful. Don't ask me how to choose, how to choose. I'm just a student. We're not talking about just a student. We're talking about real life. These one are seems like assembly holes. And do remember what we have got first. We cut contour somehow. This somehow it may be milling machine. It may be cut in a die. What you may propose cutting die, which do everything simultaneously. Outer contours and inner contours. Progressive, combined, it doesn't matter. It may be a machine which cut by laser, but by focused light. It may be some machine which cut by no something like arc welding, for instance, yeah, like plasma cutting machine. It may be chemical cutting. It may be. I may continue around a dozen of variants. And matter is only what is the most rational, not which girl is better, but which girl I need right now. Is this clear? Hello.
Yeah, clear. Yeah, clear. Yeah, clear.
No, about girls it's clear, yes.
Uh,
And pay attention. They are even. It's not one part. Why they look so thick? It's not one part. More probably they've been produced by milling machine. And in milling machine, usually we place some sheets simultaneously. No, some sheets they five sheets, four sheets, and they are cut by one motion. In order, once you're passing with the mill, you're cutting three, four, five parts at this place simultaneously. The less program, the more no, probable variant milling machine. The more problem if you need. Let's imagine that you need those parts by thousands each year. Thousands, not tens, not hundred of parts per year. Yeah? You need some thousands of them. In this case, you will use dye. You will spend time for pre-production of dye. You will spend money for this dye and so on. But next, you will do these parts like that. In case you need only some of these parts, it's not even compulsory to propose to do it in CNC machine. No, milling machine, laser machine. You may give template to your employee and just scissors by metal and send him to cut. If you need such a part once in a month, okay, scissors, template made of paper, go cut it. It comes about rationality of using both money and time, the choice of that to another technology. You need this contour. You may do it by 12 dozen variants, for instance. You select that one, which the most appropriate for you now, considering the structure itself, what is material. If it comes about glass, for instance, if it's made of ceramic, may you use milling? More probably not. If it comes about wood, may you use punching? More probably not, and so on. First, you consider what is the structure, no? And in such a way, you may what is material of structure, what are demands to tolerance of the structure. Not each technology provides the same accuracy level, roughness, tolerance, and so on. First, you're limiting yourself, like I may do this one, that one, that one, out of dozen, let it become three or four variants. And next, out of the three, four variants, depending on how much it costs in manufacturing, depending how much it costs in manufacturing, depending on the program, how much you need to produce. And next, you are selecting one or another variant. What? Let's imagine we have selected variant with milling. Agree? Hello.
agree, madam. Yeah.
Now, do pay attention on the way between this one and that one. Yeah? What is supposed to be in order this one became that one? It should be. You see it, no? It should be what? How it's called? Forming die. The problem of this damned subject assembling is those who have not studied in previous disciplines, they have permanently difficulties with understanding material in this semester. Have I said it already a dozen of times before?
Yes, madam.
Yes. Sorry, guys. Look, that I'm repeating the same things. You see right now something like little rib on the foaming die after the process of bending. No, actually, this bending, it's usually called foaming. No, no, however it's called. Let it be foaming, let it be bending. Tooling name is foaming die or foam block in English also, not only in our language. And on this forming block or on this forming die, we change it the shape finally. Once again, what part look like before? You have all the contours and you even have holes, but holes only the flat surface. What is next would be flat surface. In case you'd like to have holes here in flanges, more probably those holes would be done later. No, it also depends on different factors. If you have cuts, like in this case, no, it means that these flanges, they are not extended, they are not stretched. In this case, you may do holes preliminary. In case you have no cuts here and you have curvative contour, if you imagine this, no, do imagine this one, for instance. Now, in case you have cuts, you have no cuts in this place. In order no, in some places it would be stretching of material. In some places it will be shrinkaging of materials. It will shrinkage, it creates something like folders outside. And there is no point to do holes preliminary than in such a place. I mean side places. No, in Sylvan case we have no these side places. We need only to cut something and we need to bend it. Here is top web. Pay attention. We have chosen that we are working with tooling. Which tooling? Cutting machine, no? And bending process. Bending process. Should I find it for you, or you do remember what we're doing? Так, понятно. What is the name of equipment for sheet metal stamping, people? Не здесь надо искать, надо что тут искать. Hello. Да. Once again, propose you, my dear people, do open this class for third years. No? Let's drop it to you. This class for third years to watch and to read. Next, I have already shown you those classes, guys. Так. This class sheet metal thickness. No, let's drop it to you right now. No? Beginning of class. What is it? Sylvan, do read. What is it?
Sheet metal.
Вот тут читай. Stamping.
Sheet metal
So I,
processing. Stamping
no.
press.
Thank you, dear. What kind of equipment we need? Stamping press. Yes?
Stamping press.
No. It's also might called mechanical press. They're easy, no, like distinguish it from hydraulic presses by these wheels. They are called flywheels. You see, these flywheels, when press is working, flywheels is permanently rotating. What such a press, it has table. What second one you see, just a table. No, table and ram. Table is immovable, ram is movable. These orange things on the table, it's pedal. You see, join it with the control devices. Actually, you see a couple of big buttons here. Yeah? Actually, rock of press looks like wheel permanently rotates. It's able to transfer the engine, electrical engine rotates the flywheel. Flywheel permanently rotates, but press is immovable until you do not click pedal. As only you click pedal, ram is falling down once and going back again because it journeyed to this flywheel. One rotation of wheel is moving down and back and down and up and what are these two buttons for? Do you remember? No? I trust you've been said about. These two buttons are to take busy hands of your employee in order these hands are not appeared inside of press or inside of die during the work. Got it?
They are the buttons to operate the machine, right? That's it, right?
Yeah?
They are the buttons just to operate the machine.
No,
That's
no,
it,
no,
right?
no, no, no. Operating of machine with this pedal. Pedal is normally on the floor. This pedal for leg, for
Uh
foot,
huh. Uh huh.
it's on the floor. But this pedal is blocked by these two buttons until employee do not look buttons, they are very far from each other. In order no anyone may hold it with one palm. Two palms of employee must be on buttons and he clicking the pedal by leg, no by foot. Got
Okay.
it?
Okay. Got it.
It's
Got it.
for foolproofness. What is inside? What now press is empty. What is inside of this press? Great variety of possible dies. That is drawing process, bending process, да? Ой, так, короче, look at this. It's a die. It's a tooling that necessary to do something in such a press. The press itself do nothing. It's move up and down, no, down and up, the ram, movable portion. But both stable and ram surface, they are flat. If you just use this press for moving up, down, it's nothing. It doesn't change anything. It's apply force, but it does not change any shape. Is this clear?
Yes, madam.
Very well. And in order to do some useful work, it should be tooling inside. This tooling normally is called die. No? This die may be of some different types. First, we're talking about differences in type of operating at all. It's maybe drawing, it's maybe cutting, it's maybe bending, it's maybe flanging, and so on. Dies themselves, they may be very different. Now you see the most typical one, which consists of two plates, columns, and something inside these guts, let it be, of die. They determine what is happening inside the die. There are devices either for cutting and changing the shape, for locating, uh, mostly, да, and maybe some devices for pushing out the part. No, that one is complicated. It's so-called progress compound die, which do simultaneously. But look, first it's do cutting, да, cutting. Next it's continues the way and do drawing. It's like pulling the part inside the cutting punch in the hole of cutting punch. And it's two different operations at once at the same working station. That is why it's called compound, but it's multi-operational. It's make two different operations. Whatsoever. Another dies tab. Oh, great. Just for adult people like you are, that is necessary to watch that video later. Guys,
Ma'am,
in practical training, I forced you to read it, to watch it, and I see results are really great. Что, ma'am? 10 o'clock, I see.
you
Yes?
told me to inform you when it is
Thank
10
you.
o'clock.
Yes, thank you. We are not talking about those web breaks now or something like this. What that is really bending. Look, bending is creating the angles between the pieces or elements of workpiece. What that is really bending. What we are talking about the changing not along one contour, the shape of of your workpiece. It was forming. No, all these theoretical names, of course, during defense, you need to use correct names. Yeah? And bending maybe of some different schemes. But for instance, such kind of bending is called rolling, да, or bending by rolling. Also, in English, there is a problem that the name rolling they used for to another process completely different. One is for open die forging, and another is in so-called bulk deformation processes, rolling of sheet. And да, variety of these dyes is very great. We are talking is the most simple about most simple dye. I'm afraid it's not even reflected here in my case. No, for those children, and it's a dye. Also, we have seen it together with you at summer practical training in a movie, and there are, I hope, even tracks of those what we have seen. Uh, it is a portion of movie I have shown to you. Where to find it to front to back, certainly to the back. That is already the end of practical training. Now, still waiting for your report. Nightmare. Now, and. Oh, it was not fun. No. Look, web. No, that web would be with flanges on side. No? And as I said, you depending on whether you have cuts or not, depending whether you have stretches of these places or not. Uh, In case of cuts, this place is not stretched, so holes may be done preliminary. There are pilot holes, guiding holes. These big holes, they are analog of our, certainly, analog of our coordinate fixing holes. Maybe for pin holes, for holding this during binding, during transportation, so on. Maybe they are CFH holes for locating, for assembling. Also, you see there little, no, I hope you see them, little holes, what you see, one hole, another hole. Certainly, it's not pilot hole. I would say that it's some assembly hole, but what element is joined here, we not see. Now, we might see it again back in a movie, but not right now, we not see it. How do they do it? They have forming die, forming block, rather big one in this case. They place it by pinholes. We see, no, in movie we have seen how he located by pinholes to this forming die. Next, he placed it inside of special press. It's hydroforming press. It's not so simple like mechanical press. And one of element of this hydroforming press, now he covered it with rubber pad. No? He covered it with rubber pad. But besides of rubber pad, they have rubber cushion formed with liquid. What is hydroforming pressing, hydroforming sheet metal stamping? I have already once shown it to you. Even if you open Wikipedia, if open hydroforming, thank you, much thank you. I have typed it already. Hydroforming, you see? Computer happy to collaborate. Hydroforming. Oh, no. Hydroforming. Forming. Wiki. No. Wikipedia. Oh, my mistake. I clicked the wrong place. I clicked some advertising. Okay, right now it will appear. I hope. It will appear. Da, you see, even GIF is available. Hydroforming. You place here the flat part. Red one is flat. And no, they show it like just liquid fill in this place. No, quite clear. You understand it's not white liquid, just liquid. Da? It should be something like rubber container inside. Instead of rubber container with liquid, it's also maybe just piece of polyurethane. It's maybe just piece of rubber. It's maybe mechanical press and piece of rubber. In case you'd like, it might be hydroforming. In case you don't like it, it would be mechanical press and die with rubber cushion. Так, не надо references, нам надо копировать и нашим красавцам послать. Так, а ну-ка давайте-ка мы тут перейти к сообщению. Да-да-да. И вот это закрепить. Нет. Ответить. О, вот так. Да. In order you might click it like this and came back here. Oh, well, I'm talking, and we're not even drawing yet anything. Look, once again, we need milling machine, place here, somewhere. Да? First, we need milling machine. If I talk about milling machine, I should understand I use milling machine with CNC or not. No, let's imagine that we are using the most simple way, milling machine with CNC. CNC, oh, why it's like this? Hello. CNC milling machine. CNC milling machine on one hand. On other hand, we have decided that we need what? Oh, I placed it in the wrong place. It's not tooling, it's equipment. Suppose it to be somewhere here. CNC milling machine. Suppose it to be tooling, as we agreed, and this tooling is forming die. Let me to type it first, forming die. Form block, shorter, now. Form block. Form block. After form block, look, I have ready part. No, seems like in my case, in one case, after form block, part is ready. These errors, they are not compulsory to draw, by the way. I'm draw it just for you, in order you understand what is the sequence, where direction of moving on. But question is, form block, where it's appeared from? It's maybe of rather complex shape. No, what, or, by the word, not far from this place you see milling machine, да, how they cut it. Guys, open summer practical training videos. Open movies, watch movies in order to understand, to imagine something. No, we have no time to repeat it again right now. Да? You see where that movie is. Now. And form block, complex thing, да? As I said, it might look like something what you see at the bottom, the whole plate of complex shape and so on. Where it's appeared from? Actually, it's form block responsible for the final shape of the part, seems like, no? And no, in Sylvan case, remind what we need for form block. We need form block for side webs
For
only.
caps?
No. Caps we are not touching at all yet. For side webs. Inside webs, you have these holes for reducing the weight. In top web, you have no holes for reducing the weight. Agree?
Agree.
Deep holes. And it means that even in case of what I did here, it's already wrong because actually it's supposed to be the side, wait a second, the side web under consideration. So that place, да, ой, хулиган. That place actually it's here. Here you have no form block. You don't need form block. Мгм, мгм. So, так, CNC machine will move a bit aside because we need more place. When we're talking about side webs, we need form block. We need the CNC machine. Yes, we need it because it's also similar, no? Story. We need to cut first, next we need to do it. Also, we need press here. No, let it be hydro press now. Hydro press. No, you suppose it to write, of course, hydroforming press. No? We need here hydroforming press. This hydroforming press is responsible for. I draw it like this because it might help us remember the sequence. But actually, you may draw all lines simultaneously to the bottom of this block. Hydropress apply force here. Да? Now, I said where form block has appeared from. You do remember that here we have this means of coordination, and among of means of coordination we have cutting milling machines, CNC machines. Let's use another color for them now because it's something that is in pre-production. It's not in manufacturing. In manufacturing, we will use permanently CNC milling machine and hydropress. Here, right now, we're also going to use CNC milling machine, but we use it once. No? CNC milling machine, and this machine is responsible to produce form block. This machine for manufacturing the tooling. It's in a tooling shop. That is why I draw it with another color now. No? It's responsible for making form block. Next, it's CNC machine transfer size to form block. Form block will be responsible to transfer size to the of contours, да, to the web, да? But for this form block, before form block, да, we are going to place something that we made in this CNC cutting machine. Да что ж такое? Я же взяла кисточку. Oh, something like this. I have decided that I need, in a shop where I produce this web, I need milling machine to cut the workpiece. Next, I place this workpiece to form block as we follow this line. Да? I place it to form block, and additionally to form block, somewhere aside, I have hydropress. Hydropress is responsible only to apply force. That's it. It's not responsible for size, and that is why it's not included in the chain. You will see it now. Look, CNC milling machine. What does it mean? It has computer inside. And this computer recalculate program. Which program? Where's the program? Here is we have program. Look, at the bottom, I supposed to have program. I supposed to have brains above the O. Sorry. Program, да? Let's type CNC program at least once for you. But actually, we are typing just PR, да? Program. First two letters of program. I have program, and look, one program is responsible for Telegram is aside, no? One program, it's response. Oh, where is this appeared again? Now frame is visible, web is not visible. What? Да. One program, it's responsible for making the contour of this rib, but another program, it's responsible for cutting this forming die. There are two different models. Model of this workpiece, 3D models, I mean, yeah? And model of this forming die. Through two different 3D models and two different programs for two different machines. So in diagram we have in point. In diagram we have one CNC program and wait, sorry, doesn't look like this. And one more CNC program. One CNC program responsible to inform milling machine for cutting. What is the shape of workpiece? And another CNC program responsible to inform another CNC machine, that one, what is the shape of, no, practically it's the shape of ready part, but by inner contour. Shape of forming die correspond to the shape of ready part. Question is, where this program has appeared from? Да? Origin of coordination is a program, but it means that we suppose it to have here. Let it be. No, it's not visible color maybe. We suppose it to have here 3D model of 3D. Да что такое 3D model of frame? No, of frame and its assembly components, of course. We may write down separately after the model of frame. We may draw here different blocks with different names of parts. No, I think it's not much necessary. 3D model of frame first, да? And this 3D model of frame is informing, let it be CNC program about sizes of, да, ну, workpiece. And CNC milling machine here, да, which is responsible for form block. Form block, it's already not element of airplane. You need to create first another set of 3D models, 3D model of tooling. 3D model of tooling. Maybe you have another toolings, not only that one. Or this 3D model of toolings. Wrong color. 3D model of tooling responsible for control, creating the program, CNC program, which next transferred to CNC machine, and CNC machine recalculated and do form block. That was one line, you see, of size transferring. And here it's another line. How they are related? Actually, 3D model of tooling you do also by copying it from 3D model of your frame, of your parts. First, you have 3D model of frame. Next, from 3D, using 3D models of frame, literally like molding in these CAD systems, when you are copying sizes from one object to another. Yeah? You are making this, Irina Alexeyevna, good afternoon. You are making this 3D model of tooling, but before you start come up with 3D models of frame, of course, you have some theoretical data. More probably, it's in tabular way. So first, we will write down here something like theoretical tables. Or it's maybe the set of equations. They are usually considered like mathematical models. Yeah? Mathematical models, no, we usually type it like this. Whatever you type here, it comes about theoretical data. It's not even a drawing yet. Where we might took drawings, where these drawings will appear from. First, wait a second, we need to draw a rectangle. Theoretical tables and another theoretical data we are transferring, we are changing them in the 3D model of frame. Yeah. Next, by 3D model of frame, we are going to do 3D model of tooling. Moreover, not right now, but somewhere else next, we will have here 3D model of 3D model of assembly G and another tooling. We might type it at once like 3D model of assembly tooling. It's not compulsory only assembly jig. It might be some template or mounting standard or whatever you need else. 3D model of assembly jig and tooling. Somewhere aside, where it's appeared from, exactly like it was with 3D model of this tooling. We have 3D model of frame, and next we have, it's like parent of 3D model of jig, yes? And as a result, we might have here 3D model of jig. Brush, arrow, like this. Now, drawings. Inside of origins of coordination, we might have drawings. Where drawings appeared from? Look, no, for instance, drawing of jig, if we need drawing of jig, where we may take drawing of jig. Suppose it to be in origins of coordination, yes? Uh, drawing, drawing, we might generate, as we have seen it maybe in our CAD tooling, in our CAD tooling classes, drawing might be generated from, here is we have drawings of assembly tooling. They appeared already after 3D models. Now, in case we have started with 3D models. In old-fashioned techniques, of course, it's another order. No? When we have no any 3D model at all. If we need here 3D model of frame, we need drawings, it means that also sorry that I do it like ugly cloud, we may generate drawing, for instance, for some part. No, for instance, if you'd like to do something by drawing, not by a CNC machine and not by template, and so on. Look, however long it was, it's only about the only part, either left or right web. And I said, top web is very similar to what do you have, but top web is, what is it? It has no form block in chain of size transferring. Literally, if we'd like, we may do it like, look, I will remove again, will clean up the place. What we might do here? Look, I'm just copying this place now. Oh, sorry. Replace it here. And the only problem is, where at beginning of this place, CNC program, where it begin from? Silvana, I need your help now.
This CNC machining is for top web, right?
No, yes, look, посмотри, we have this CNC machine, which going to cut contours of top web, but you still see that this place is empty, or this relation, it's empty, it's like hanging in the air yet. Where beginning of this CNC program? Where it was beginning of this CNC program? Look, in 3D model of frame, yes?
Yes.
Where beginning of this CNC program then?
It's from 3D model of frame and another one is for 3D model of tooling.
No,
So this
the
must be
same
the 3D
place.
model of frame.
No, it's one model of frame. Model of frame include 3D model of one web, another web, of cap, and so on. Not like you assembly models that you make, yes? This 3D model of frame altogether, it consists of separate parts. Is it? Does it?
Yes.
Exactly. So if you'd like, you may type here 3D model of frame, and next you separate, like you each time you are typing simple another block here over the 3D model of frame, like 3D model of web, 3D model of another web, 3D model of this, 3D model of that, and so on. It just litters the diagram. No, if it's more convenient for you, you will do it like with detailization. No? And look once again, what we did. We just have joined it, like in back direction, in backward direction. We have joined the part with so-called origin of information, with some theoretical tables and models, or 3D model, for instance, how from 3D model we pass to the ready part sizes and shapes. We have drawn history of part manufacturing and history of part pre-production. What is coordination line? What is this chain of size transferring? But literally, it's a history of each part, how it's appeared. And do pay attention, mostly all the blocks in diagram, they are joined with lines. They are joined with some lines. But one block is still hanging like air balloon, hydro block. It has no relation to anything at all. Why? I said you sometimes already. It's not included in the chain of size transferring. It just applies a force. It's not responsible for the shape. It just not like in that picture. It just apply force, but what is shaping place here in this picture? No, which color is responsible for final shape?
The
Whether it's rubber. Say, come again.
the green color mold or
Green.
the
What is
block,
the green color? It's forming
that's the
dia of
form
the
block.
movement. Exactly. That is why we think that press is not responsible. But in this particular case, press is not responsible for sizing, and it's not included into any chain. Just hanging. It's okay. In another case, it might be what we bending that we have seen here. No, what that one, we breaks, we bending, so called. No, it's usually used for long parts. It may be used for short parts, but mostly it's used for long parts. We break. What is the problem with the break? Look, how this shape is appeared. You see that because of motion of this red, it's called dead gauge, something like stopper. And this position of this stopper determine what? It's determine the length of that to another element of part, that another feature of part. To see in slide, yes, obviously. In this case, such a machine, in case this stopper, it may be adjusted by template, you may do it manually, like you place here template, or it may be measured by ruler, or it may be CNC controlled. Modern V-brakes, they have CNC control. They have controlled by computer. And it means that they automatically change position of this gauge. In this case, machine is responsible for shape. Like, yes, it's also a mechanical press. Literally, such we brake, it's mechanical press. It even has this flywheel also, as we have seen in press before. But in this case, we think that shape of die is responsible, but die are universal here. Die are not special. They are not included usually in the chain size of size transferring in V-brake dies because they are supplied together with V-brake itself. And machine is responsible for size and shape because machine is controlling this CNC back gauge, and due to this, it has that or another length of feature. But in this case, in this bending, it's just simple bending die, which is placed in the simple primitive mechanical press, and in this case, die responsible for shape. In case of a brake, and press is hanging. In case of a brake with CNC, CNC we brake responsible. CNC we press responsible for a shape. It's included in the chain. In case it's primitive we brake, it's not given here. No, do imagine primitive we brake. We have such we brakes. No, usually they look like presses, like what we have seen in the beginning of explanation. But here you have press with rectangular or square table, and there it will be very narrow and very long table, and no difference practically. Looks like this, but table is narrow and long. It was the only part yet by now, and it was part made of sheet metal. Once again, what it looks like. In case part has any flanges, we agreed that we need forming block here. First, before we use forming block, we need to cut the piece into its shape, now, like it was in the picture. And next we place it onto this forming block. And finally, we have final shape of the part. But say me please, holes. Where holes has appeared from? You see? We have not mentioned holes here, yes? In picture, in diagram. We skipped it. Have we skipped the
No.
hole? Where holes are manufactured then? In which machine?
CNC milling machine. In equipment, there is a CNC milling machine.
You understand it. Thank you. Thank you so much. Great student. Yes, CNC milling machine may mill, may drill, may even, if you insert not blade tool, but something like grind tool, something like end mill, but instead of end mill, it will be filer, Ну, такой circular cylindrical. No, do you imagine like pencil, and this pencil is covered with grains, with this grinder material, It may even grind if necessary, because it's just rotational motion and motion along some contour. By the word, I forgot to say here, CNC milling machine, better to type here not even CNC milling machine, but CNC milling router. There is special type of machine which is called router. What is the difference? Right now, once again, will show you because I'm afraid you forgot already. Why it's router? Because it's work along the route. Router. Now this may mostly applied for internet and electronic devices, but before this, machine. Замечательно. I have wrote machine instead machine. Router, and let me to show here. No difference there. It was given for you. CNC milling machine looks like this. You see, it has rather short table. No, short and narrow. Let it be. Also, like with press, it's maybe rectangular. It's maybe typically CNC machine has such a table. It's maybe much longer. For long-sized parts, such a table, it may reach 20, 30 meters. There are such machines. Even couple of places with spindle would be, in order to speedize the work, it would be two places where mills are inserted, and they work simultaneously, but work according to different programs. And in contrary to CNC milling machine, CNC milling router looks like milling router. It looks like big table, and over this, thank you, much useful. Here is now like a table, and over this table you have something like gate with movable spindle. Such machine is only for two-dimensional motion. You see, huge table, And over the table, it's something like bridge, and this bridge is moving along. What that is thin simulating rotor, no? And telegram here is. Let's answer. Milling rotor. In contrary to milling machine. So when you are talking about forming die, better to say it was milling machine. When you are talking about sheet metal parts, more probably it was milling rotor. And what it looks like, you have seen, it's not the only part which cut in such milling rotor. No? Inside of sheet, and a sheet is packed. There is stack of sheets. No? Inside of one sheet, they are cutting simultaneously some dozens maybe of different parts of different shape in order to save material. When they remove here this part, more probably he removed simultaneously some parts. He or she, it was lady, yes, in a movie. No? She removed some parts because it was some sheets at the milling rotor table. And you see, even this milling rotor table, it's like simple wooden plate. No? But over this table of milling rotor, it's moved to the bridge with CNC controlled device. Let's stop. So one, thank you. It was much helpful. You did your job well. You have reminded to stop. It's me who have not stopped on time.